All right, hello everyone. Uh, Complex conjugates. We talked about the term conjugate when we were dealing with radicals. You might remember, for example, if we had something like 2 plus root 3 in a denominator, we needed to get rid of that by multiplying by 2 minus root 3, because then that would cancel out the radical and we could get an expression that didn't have a radical in the denominator. Complex conjugates are a similar idea. So remember, an imaginary number in standard form, an imaginary number is a plus bi. The conjugate of a plus bi is just a minus bi. So for example, if we wanted to find, so the conjugate, we have 3 minus 5i, then the conjugate would be 3 plus 5i. If we had negative 6 plus I, the conjugate would be negative 6 minus I. We just had 7i, the conjugate of 7i would be negative 7i. And the other thing is to watch out to make sure that things are in standard form. If they're not, you need to flip it around. So if you have 8i plus 2, well, the complex conjugate of that, we're always changing the sign on the imaginary part. So it would be a negative 8i and a positive 2. Complex conjugate, you're just changing the sign on the imaginary part. And how that, the reason that's helpful is because that lets us get rid of our imaginary. If we multiply these out, we get 9, and we get plus 15i minus 15i. So those are going to go away. And then we have minus 25i squared. And plus 15 and minus 15 go bye-bye. And I squared is negative 1, so minus 25i squared becomes plus 25. So then this would be 34. If we take 6, negative 6 plus I times negative 6 minus I, we get 36. Minus 6i plus 6i, which cancels out, minus I squared. And of course, I squared is negative 1, so minus I squared becomes plus 1. And for that one, we get 37, and so on and so forth. The complex conjugate, you're just changing the sign on the imaginary part, and if you take a complex number times its complex conjugate, you get something that is only real. Let's see. Yo hablo. Tú hablas. Él, ella, usted habla. Nosotros hablamos. Vosotros habláis. Ellos, ellas, ustedes hablan. Man, this conjugation thing is so complex. Because standard form of a complex number is a plus bi, we can't leave any expressions with imaginaries in the denominator. So we need to use the idea of complex conjugates to get rid of any imaginaries that wind up in the denominator. Remember, division is the same as a fraction. Like if you take a divided by b, that's the same as a over b, a fraction. So we need to deal with that if we have any complex numbers or imaginary numbers in our denominator. So say we wanted to simplify various expressions. Start with say we have 3 over 5i. Now, if it's just an imaginary number, this is a unique case where we don't need to deal with the conjugate. We could multiply by negative 5i in numerator and denominator, but if we did that, we get a 15 up here and a 25 down here, and now those can reduce. So if down here you have just an imaginary and no real part in your denominator, then you can just multiply by I. And to keep things easy, I would actually multiply by negative I, then your negative is in the numerator instead of the denominator. So you would get 3 times I in your numerator, that's negative 3i. I times well, I'll just write negative 3i over negative 5i squared. We know I squared is negative 1, so that becomes a positive, negative 5, and so we wind up getting minus 3 over 5i. Because of standard form being what it is better practice to write the fraction over here in the complex number after it rather than putting the I in the numerator. Now, if we have a complex number that has both real and imaginary parts in the denominator, then we have to deal with that. Say we wanted to simplify negative 4 over 2 plus 3i. Well, to get rid of that imaginary in the denominator, we need to multiply by the complex conjugate. We can multiply by 2 minus 3i over 2 minus 3i, which means we do need to use the distributive property in the numerator there. Negative 4 times 2 is negative 8. Negative 4 times negative 3i is 12i. In the denominator, we get 4 minus 6i plus 6i. The imaginaries are gone. That's good. And then 3i times negative 3i is minus 9i squared. I squared is negative 1, so that becomes 4 plus 9. So our denominator is 13. And because, again, standard form is a plus bi, we do want to split up this fraction. The denominator is 13, so we've got negative 8 over 13 plus 12 over 13i. Negative 8 over 13 plus 12 over 13i. Right? And you do that anytime you have a complex number in the denominator. You could have, it doesn't matter what's in the numerator. If your numerator is imaginary, you do the same thing. So you have 6i over negative 5i plus 2. Remember, your complex conjugate is changing the sign on the imaginary number, not on the real number. So your complex conjugate needs a positive 5i, still plus 2. You keep the real part the same, and you change the sign on the imaginary number. So you can multiply by 5i plus 2 over 5i plus 2, or you can write 2 plus 5i. It doesn't really matter. And again, in the numerator, you've got the distributive property. We've got 30i squared plus 12i. I squared is negative 1, so, and in the denominator, we have negative 25i squared minus 10i plus 10i plus 4. And I squared is negative 1. That's positive. So for our real part, we have negative 30 over 29. Plus 12 over 29i. So once again, if we have any imaginary in the denominator, we need to get rid of that imaginary. Typically that involves multiplying by a complex conjugate, then distributing and simplifying whatever is there. And remember, the complex conjugate means you're changing the sign on the imaginary part, keeping the same sign on the real part. Most complicated problems are where you have complex numbers in the numerator and denominator. So for example, if you wanted to simplify 3 minus 5i over, sorry, let's grab the bad marker, negative 4i minus 2. Well, you need to get the imaginary out of the denominator, so we need to multiply by the complex conjugate. We change the sign on the imaginary part, keep the sign on the real part the same. So we're multiplying by 4i minus 2. And then we have to go full difficulty and FOIL out the numerator there. 3 times 4i is 12i. 3 times negative 2 minus 6. Negative 5i times 4i is minus 20i squared. And negative 5i times negative 2 is 10i. And then in the denominator, we have negative 4i times 4i, 16i squared. Minus 8i plus 8i goes bye-bye. Negative 2 times negative 2 is a positive 4. Then my I squareds are negative 1, so this goes away and becomes plus 20. This goes away and becomes plus 16. When we combine our like terms, we've got 22i in the numerator plus 14 over 16 plus 4 is 20. Then we want to put that in standard form, so real first, imaginary second. And we also need to reduce fractions anytime. They're 14 over 20. Both of those are divisible by 2, so that reduces to 7 over 10. 22 over 20 are also both divisible by 2. That reduces to 11 over 10, and that is imaginary. That's our first example, dividing complex numbers. We'll do one more example. Let's say we have negative 6i plus 1 over, I don't know, 7 minus I. Multiply by the complex conjugate of the denominator, 7 plus, and then multiply everything out. FOIL, we've got minus 42i, outer gives us minus 6i, inner gives us 7, last gives us I'm sorry, the outer should be minus 6i squared. And then in the denominator we have 49 plus 7i minus 7i minus I squared. Our I squareds become negative 1, which leaves us with plus 6. And the minus I squared becomes plus 1. So then we wind up with negative 42i plus I, minus 41i. And then 7 plus 6 is 13. 49 plus 1 is 50. None of those can reduce, so we just put the real part first and the imaginary part second. You get our simplified complex answer. That's how we go about dividing complex numbers. You just have to get rid of the imaginary in the denominator. And it's a good review of properties of doing arithmetic with complex numbers, because you have to multiply and add and subtract as you're going through the process of division.